Hi guys, in this video I'm going to take you through how to install TensorFlow Serving, or a simple intelligence version of TensorFlow Serving in your local box. So we have forked an open source version of TensorFlow Serving to make it, modified for our use case and our service. So TensorFlow Serving is an open source library used for deploying deep learning models in a production-like scenario. Later on in another video, I'll cover how to do the Python client file and the saved model file. In this video, it would be a step-by-step execution of each of the commands that's already given here. You can actually follow it. You can do it in parallel if you want. If anything goes wrong, you can cross-refer on the video. This would be a complete live demonstration of each of the steps. So just in case something goes wrong, you can refer it. How to make the Python client file is explained later in the tutorial. I would be making a separate video on how to do that, how you can make a Python client file to call the TensorFlow serving to do different inferences on your model, like predict, classify, regress, so on and so forth. Saved model file is something that you get after you convert your weight file. Weight file is a file that you get after you train your TensorFlow models, or the checkpoint file or the weight file. You need to convert that to a serializable format called the saved model file. Both the files are checked in to our examples here. The git branch is given here. We'll be git cloning that branch for compilation. So both the files, both these files, if I take it inside examples, the inception client file and the saved model file. This is the client file for the inception model and the saved model file to convert the checkpoint file to the saved model format. It's already checked in here in this directory, in this GitHub branch. It's already given in the website. You can go through it, but I'll be making a separate video explaining how to make that file. But right now, let's do the installation and have a image recognition model running in our local box. So let's do it. You can do it in parallel with me. So I'm going to use a fresh machine from AWS. So I'm going to connect to that. It's a brand new machine that I commissioned, so there's nothing in it. I just took the machine from the community. Community is where you get machines with a couple of pre-packaged already installed for TensorFlow. So I just took it from that community from AWS. I'm just going to use this machine for the installation. You can use your local machine, or you can just get one from Amazon. It's up to you. For this demo, I'm going to use this. You can follow each of the steps with me. So first we need to make a directory. Here is where all my code for the TensorFlow serving will reside. So inside here, I would go inside that directory. That's where everything would be. Now I need to install the Bazel. Bazel is used for compilation. So Bazel would kind of make a container with symbolic links to all the libraries. So you can run finally your serving models or serving client later on. It would make a container for you with all the symbolic links to all the Python path libraries. So we need to get that installed. So let me install the sh file. This is taking some time to download. Maybe later on, if an installation is taking way too long, I would probably edit that part of the video so that the video is a little bit more shorter and concise. I'm not sure whether I'm going to edit this part out. We'll just wait it out and see. It's not too long, I guess. So it's good to have a continuous video so that you can you don't have to pause. You can just follow it with me. So let that get done. So it's pretty much done. So it's okay, not that bad. Yeah, it's done. So next one would be to change the permission of that. Let me just clear the window and start from home. So I changed the permission of that. Then I run it. And finally, I have put the file, once I compile this, the entire executable goes to the basal executable, goes to home bin. So that'll be home Ubuntu bin. So I need to put that in the path file. Otherwise it might check in the user bin and there might be nothing there. So I put it there. Then I need to install the RPC, gRPC, Google RPC format, which is pretty much used for the communication between Python client and TensorFlow serving. Later on, if you want to skip these installation steps, I've already given the link to a Docker file. So you can use that, so you can skip all these installation steps with just one Docker command. If you're more comfortable with Docker, if you are used to using Docker, you can use that. And so all the steps which I'm showing right now will be all done with just one single command and would just make a Docker container for you. So that's one way of doing it. And the next one, we need to install all the libraries that is needed. So let that get installed. So these are different libraries like curl, git, and different Python packages like NumPy that you need for TensorFlow serving. Next, we need to clone our code. So as you can see, this is we've forked the code, the TensorFlow serving code, from the main TensorFlow to our own subdirectory, simple and tell. Under there, we've forked it and we've slightly modified it to make it suitable for our serving purposes. So what we're going to do is like clone that here once this is done, and we're going to compile it. And the compilation is going to take some time because it's a lot of code needs to be compiled. Maybe during those sessions I'll pause the video so that the video is not like too long. You guys can pause it as well when the compilation is going on. So let that, it's reading database. This usually takes a while. I'm gonna clear the screen. Let that get done. Once that is done, 95, it should be done soon. Yeah, probably when I'm doing this would be the command where I'm building it. That usually takes a while, so I'm going to pause the video during that time. It says unpacking all those packages that we need for our purpose for running TensorFlow serving. Once that is done, I'm going to clone this guy and take it from there. Almost done, guys. Great. That is done. Now I need to get all my code. As you can see, this is doing a recursive submodule. That means it needs to get the submodule packages as well, like TensorFlow and all that. So it would get all those packages also for you. And you need to also configure TensorFlow, which is coming in the later steps. So let that get done and we can configure TensorFlow. For our purpose, for running TensorFlow serving, you don't need all the libraries like OpenCL and CUDA support, unless you are running on a GPU machine. But for running this example, or running for serving or testing for serving alone, I'm going to give no for most of that, because also because I'm running on a CPU. But if you're running on a GPU and you need those supports, you can like go to the documentation for TensorFlow and look into how you can procure those libraries online. There was another code that I run that required training on a GPU, and I had to get those libraries. So yeah, please look into that. And then I'm going to go into serving. Then into TensorFlow, and then I'm going to do /, maybe I'll clear the screen right now. /configure. So this would open the configuration window. It would take a while to get installed and everything. So let's see. So once that configuration window starts, you can configure the Python path and set different libraries and everything. Oh, there's something wrong, it seems. Oh, we have an error while doing a live demo. but we'll fix it. Don't worry. You have okay. I have an older version installed rather than this or higher. I think this happened because I took an AWS machine from the community. So the community has an older version. Maybe it's under ls user bin Bazel user bin. Let me just clear that again. User bin Bazel. Yeah, there is a version here, but the version that we want to use is under home Ubuntu bin Bazel. So that's the we want. For now, for the demo purposes, I'm going to copy this to there and fix, we're just going to, and fix the error for now. I don't need the older version, so I'm just going to copy that. That's the way. There are different ways of doing it. I thought I already set the path, but somehow it took the other version. But that's okay. But this should fix it. Great. Now it's extracting. Let's see whether it works. Well, once that is done, you have to set the default Python path and the Python libraries. The rest, as I already said, you can give as no, unless you're using a GPU. So let's just reach there, and after that, it would be a long process because I'm about to compile TensorFlow serving from the root. That takes around 20 minutes. So I'm going to pause the video when that happens, and I'll resume it once the entire installation is finished. So you can pause as well if you are doing a live installation with me. You can pause the video during that step. Oh, great. So it's Python. That one, you can give the MLOG support. Sure, it doesn't hurt. The rest of them you can just give no. We don't need that for our purpose. Like I said, if you're using a GPU and you want all that, then please do refer the TensorFlow documentation to get those libraries. And finally, great, I'm gonna get, okay. Next step, oh, sorry, I skipped this. That later, that is how you run it. That is the checkpoint file that you need to run it. So before that, I'm gonna go one step back and I'm going to compile it. Great, compilation is getting started. Once it starts, I'm going to pause the video because it takes around like 20 minutes or so to compile, and you'll be just staring at the screen for 20 minutes. So I'm going to pause it. You can pause it now as well once it starts. And once that is paused, once the installation is finished, I'll resume the video and we will go into how you can run a model in your local machine and recognize a picture, any picture you want. It will be able to recognize it. We'll go through that right after this installation starts. It's taken a while. Why is that? Yes, it is starting. So the installation is starting. So like I said, it's going to take a while. I'm going to pause it. Till then, I'll be back right after the installation is finished, and we'll resume the steps from that point. Thank you. Hello, welcome back, guys. I think the installation is finished at this point. The entire compilation is done of TensorFlow serving. Now let's get to the part of actually running the models in our local environment, how we can run it, how we can serve it using the TensorFlow serving code, and how you can invoke the client to do some kind of an inference. So that is done. Next, we'll download the weight. This is the weight file or the TensorFlow checkpoint file that you get right after you train the model. Next step is to download that into your local machine. So let that go on. let me just reset this. So the entire checkpoint file is getting downloaded of the inception model. Inception model is a model that the Google have given online for demo. So we're going to use that for our sample, just to learn how to do all this. If you have your own model, you can use the same format and upload it. Our examples are slightly different because we need to invoke those models using remote procedure calls. So I'll explain that in another video, how to upload your Python client file and your saved model file into our service. I'll be explaining that a little bit later. So right now, let's just focus on getting this running on our local box. So we have the weight file downloaded. Now we're going to unzip that. Great. And then we're going to, this is the saved model file. The saved model file is going to convert this inception file into the same model executable is going to convert this inception weight file into the save model serializable format. If you want to look at the code, it's actually given in our examples, simple and tell. You can go to GitHub simple and tell. This link is given in the website. You can look at serving, you can TF serving. Don't look at the main examples because the examples are slightly modified for our purpose. So look at our version that is forked from the open source version. So you can look at examples and you can look at inception client, and this has ways how which you can run it. And there is also inception saved model, which converts the checkpoint file to the saved model format. So this converts to a serializable format. There are a bunch of functions you need to give, like pre-processing, how you need to pre-process the image into a format that your TensorFlow model would recognize. So all this is given in this file. I'll be taking a separate tutorial on how to make these two files, the saved model file and the client file. The client file needs to be in this format, init and process. And in this process, you'll be calling the different TensorFlow APIs like predict, in this predict, and model name, and input is the input that the users would give for your model. It could be the byte file of an image, so on and so forth. And the init would have the server name and also the data directory. The data directory can be a text file. Let's just not get into detail in this video. We'll just focus on executing it. I'll make a separate video explaining in detail how to make these inception client file and the saved model file at a later time. Okay, so I'll be doing that. I promise you guys that. But let's just run this, get this up and running, and have it recognize a picture, have the inception model recognize a picture, and see how we can run it on a local box. So it has been changed into a serializable format. It's been exported to this directory. Great. Now what we need to do is run it. So this will run. This is in this diagram, if I explain, which I explained earlier. In this diagram, the TensorFlow serving would run and upload this model to the memory. So that's what we're going to do here. We're going to enter that so it is uploaded to the memory. Now it's running right now. Since I don't want to open another window, I'm going to execute this in the background. Okay, so let that go running in the background so that I can use the same terminal to execute the next command, which is the client command. The client command would use an image. So I don't need to do this since I already compiled from the root. I don't need to do this. So the client command would pretty much recognize this image. So this was a picture of a person and it recognized that. I don't have any pictures in this machine, so I will download a picture. So let's say that elephant photos or something. I'll download that, maybe this image. So I need to go back. I need to copy the copy image address, and I will do a wget. Boom. So that just downloaded that. So that would be the name of the image. Now I can give this command to recognize that image. So I will take this and I will give this image name, and it needs to recognize the image. Let's see. Yes, it did. It recognized that it was a tusker, African elephant, later on, or an Indian elephant. So that has really high probability. Then there are other predictions like Komodo dragon with really low probabilities, but we don't have to worry about that. But we got the higher probabilities right. Indian elephant, African elephant, and the tusker, we got it right. So that's how you pretty much do it. Yeah, different classes tusker. Yeah, it has predicted that. So we're good. That's how you make it. In the next tutorial, I'll be going through how to run the same thing using a Docker container. So you can have the entire, we'll have a Docker file with all the installation there. So you can just run that Docker and all the installation would be taken for you with just one command. So you don't have to like repeat this command over and over again, even though it's quite straightforward. So let me tackle that in the next video. You can go through this video and, you know, like in parallel, execute the commands with me, and, you know, just in case anything goes wrong, you can refer back to the video, or you can just look at the text files that are already there. Yeah, I hope you find this tutorial useful. Thank you for listening, and we'll just go to the Docker stuff next. Yeah, let me start with the Docker. Thank you guys for listening.